So one thing that we probably don't realize is that we have a giant blind spot in how we think about solutions. At least we probably do. And that's because we typically say, okay, I'm going to take this mass of my powder. I'm going to dump that into my known volume, which I know very well. And because I now know the concentration, I know what's going on in that solution. Well, that's great and wonderful, but what liquid were we putting in there? Was it a buffer? Does it have other compounds in it? If so, are they going to be interacting? Not reacting, just interacting. This is the blind spot that we have, all of the other species that we might have present in the solution. In other words, when we have a solution, we think that this is the only thing that we have present in our solution. But what if we also have a few other ions around? You can see that +2 is going to do a great job of attracting these negative charges. The -2 is going to do a great job of attracting the positive charges. And so we have two different species in solution, and they're going to be interacting with each other. We account for that by thinking about ionic strength. And this equation looks a lot nastier than it actually is. What we're going to do is we're going to consider every species in our solution. Now let me go ahead and show you this. Suppose we had some sulfate ion in there. We'd have another 2-. We're going to have an H+, and we're going to have another H+ in there too. So now we can see that we have 3 different substances that we put in there. But notice we're going to have a total of 6 different ions that we need to care about. And we're not going to care about the concentration of the sulfuric acid. We're going to care about the concentration of that ion, and that ion, and that one, etc. So when we go through this, go ahead and get my red ink back. We go through this, we're going to say, what's the concentration of each ion, not its parent species. We're going to take the charge and we're going to square it, because we expect that the charge is going to have a really big impact on how big of an effect we see. So charge times this, concentration times the square of the charge. We do that for every ion present in our solution. We add them all up, and we multiply it by 1/2. In other words, we divide by 2. And you can see here that's just been compacted into this final form. So we always need to do that for each species that forms an ion in our solution. Now when we calculate our ionic strength, that's going to be something that's important for figuring out certain effects. And the biggest of those is going to be activity, and that's going to be our next video.